In this video, we'll show you how to effectively achieve your mining production targets using K-Mine software, specifically the scheduling module. The scheduling module helps you develop plans for mining operations over any chosen time period. The main difference lies in the duration and input data. You can create plans in the scheduling module using two methods. Today, we'll focus on the automatic approach, discuss its key advantages, and show you practically how it works. Each scenario in your project contains a special feature called Solution Finder, designed to automate the search for the best scheduling solutions. With Solution Finder, you can quickly estimate how many years it will realistically take to mine a deposit, check whether your goals are achievable, identify potential bottlenecks, and find the optimal scheduling solution. A blue check mark next to intervals in the project tree indicates a successful calculation according to your specified criteria. You can also limit calculation time, but keep in mind, too short a duration might not yield a viable solution. For initial iterations, we recommend creating solutions specifically for ore extraction. This gives you insight into how long your reserves might last, the production volumes per period, and other critical parameters. Each interval with a calculated solution represents a set of blocks that need to be mined to achieve your production goals. To help users better manage the process, we've included information about remaining material in each area. This allows you to clearly assess the completeness of extraction and adjust your plan if necessary. For example, if after completing the 10th interval, a significant amount of material remains, you can adjust the goals for the 11th interval to ensure the majority of the remaining reserves are mined. You can set production targets for one type of material or multiple materials simultaneously. For ore specifically, you can also add quality indicators. To enhance visualization, let's build a run-of-mine chart and examine the results from our initial calculation. This chart is flexible, easy to set up, and clearly displays material volumes per period along with quality metrics. Initially, capital stripping is needed to access the ore, but subsequent periods become more predictable and easier to manage. Now, let's create a more realistic scenario. For the first two periods, we won't emphasize significant ore extraction. These are primarily dedicated to capital stripping. Starting from the third period, we'll set specific targets for ore extraction and waste removal. If needed, you can also limit extraction from other areas using the dedicated menu under Target Settings. This lets you set both overall extraction volumes and detailed parameters for specific material types or areas. These settings are highly flexible, enabling precise adherence to your operational goals. Let's now generate a chart based on calculations with higher target requirements. As shown, the first interval involves only stripping activities. Ore extraction begins in the second period, ramps up in the third, and by the fourth period, your operation reaches its planned production capacity. This capacity remains steady through to the 11th period, after which mine operations gradually decrease. Overall, material volumes remain stable and controlled, ensuring smooth execution of your mining plan. The planning results are represented by sets of blocks, so users can always review the extraction sequence and make informed decisions based on these outcomes. Thus, by leveraging the scheduling module and results from the Optimal Pit Boundaries module, you can create an effective, realistic mining schedule. Select the number of pushbacks needed, experiment with production targets and area extraction settings, and achieve the optimal mining results.